Record. Sorry, it starts recording when I log in. That's like 5 minutes before class even starts, and then I just stop it because I don't want like 10 minutes of just awkward silence on the video. It's kind of weird. Okay, does it tell you guys it's recording? It tells me it's recording. Okay, I'll reshare my screen now. Anyway, back to Bézier. He's a French engineer that figured out the mathematical underpinning for these B-splines, a way to sort of approximate these really crazy curvilinear geometries that they would use for car bodies, you know, basically built on performance, aerodynamics, and handling stresses from making corners and turns and things like that. So all of this stuff has mathematical and historical underpinnings going back even centuries, right? Lofting is a term used from the shipbuilding industry from a long time ago. It was the idea of taking a complex shape of the hull of a ship and approximating the actual cross sections through it in order to create and steam bend and laminate the sort of wooden ribs and skeleton underneath. So it's like the reverse of Lofton in our modeling tools, right? Where we take the cross-section curves and then skin in between them to create the actual shape. So suffice to say, back to this, I'm going to go ahead and create one of these Bézier splines. You're welcome, Pierre. There we are. So next time you're watching an F1 race and they say Renault, you can be like, yeah, Bézier curves, bro. All right, so let's bring that up. Let's bring that up. No, wrong one. Here we are. Yeah, I'll move that one up. Just moving these up with the gumball in perspective view, just trying to create a quick matrix of curves here that I can loft together. Type in loft, and I'll just select these all at once. Boom. All right. You know what? Instead of lofting them in Rhino, I'll loft them in Grasshopper. Why not? Nice. Well, take care of that really quickly. Go ahead and open up Grasshopper with my command line. While that's happening, I'm going to, oh, I thought I was going to turn off this grid. I hate this grid. This grid is like the largest visual assault on the human eye in history of the world, I think. But maybe I'm a little over dramatic here. It's Monday. Give me a break. Options.
That's how my mom describes me.
It didn't take us long to get to the your mom jokes here today. You can tell it's a Monday. All righty. Excellent. All right. So I have some pieces of geometry I've created in Rhino, and I want to reference them into Grasshopper in order to build off them parametrically. So first and foremost, when I have some ingredients that I'm going to need in Grasshopper and they're already built in Rhino for me, or I've modeled them or extracted them from Rhino, I need to go to the params tab, geometry, right? Here's all the different sort of placeholder geometries. In this case, I can specify curve. And I can right click. I can say set multiple curves. Grasshopper disappears, allowing me to select the actual reference Rhino geometry. And I'm going to go ahead and select all 3 curves at once and hit enter. That works well. All right, great. Now I have a widget with a list of 3 curves, right? So I have 3 curves here. Right there it says a reference planar curve, and a reference planar curve. 3 of them right there. Go ahead and go to Surface Tools and find the loft command. Of course, the ingredients for loft are section curves, so that's handy. Here we are. Now again, the information flows from left to right. So if we change anything referenced into this widget on the left, right, the changes will propagate to the left lofted surface that's generated to the right. Right, so I'll, for instance, go ahead and move this original reference curve. There we go, right? So we start to just, maybe I turn on its points and manipulate its points a little bit. There we are, all right. You know, I can also move this thing. You know, what's nice about this is I don't have to draw everything on the XY plane. I can sort of sculpt 3-dimensional curves, like almost like the roller coaster tracks, right? And have them moving in X, Y, and Z all at once as I move along them. So I could even make this surface sort of here. Let me finish that thought. Make that surface an elevation kind of contract and then swell, larger and smaller, different places as well, just to give it a little more. There we are. Why not? That's a nice looking surface. Pretty handsome if I do say so myself. All right, so I have a surface. And in this case, I'm going to rebuild this surface. I'm going to try to give it some more isoparms. Right now, I think by default, isoparm density is pretty minimal. There's more than one way to do this, but since I'm doing this in Grasshopper, I'll go ahead and take a look at, I think there's a rebuild somewhere here. It's not an analysis. I'm guessing it's in utilities. And yet I don't see it here. So when in doubt, what do? I double click on the canvas and I say rebuild surface. Oh, there we go. Rebuilds an untrimmed surface using U and V parameters. All right, the degree, right? And the number of points in the U direction, number of points in the V direction. Now this U and V, we haven't really talked much about surfaces. This is like a precursor for project 2 when we really talk a lot about surfaces. U and V is kind of referring to latitude and longitude, right? So the number of U lines would be, number of U isoparms would be like, let's say latitude, and the number of V isoparms would be like the number of longitude lines or curves running through this thing, right? So anyway, these are all, I think by default, these are the degree of curvature set to 3. I want to keep that. This is set to 10, and this is set to 10. You know, I'm going to actually make slide bars. We'll make those variables. We'll make those independent variables. So each one will get its own slide bar. I'll constrain that to integers. I'll have at least one. I'll go up to something crazy like 100. Why not? I mean, that's probably over the top, but hey, why not? I'll live a little today. And if I'm wrong, may my computer just go completely non-responsive, which might happen. All right, there we go. Okay, rebuilding the surface. And rebuild surface. Okay. When I go to 1, it really sort of distorts the surface geometry as I rebuild it, but then it starts to get more and more. Let me just go to like 20. 20 seems like a more realistic number. I'll just double click on that value, type in 20 and hit enter, and I can just be very precise there. Now it doesn't actually show us or preview the isoparms for us. That's annoying. So what I'm going to do is I'm going to extract wireframe. Wow, can you tell I haven't done this in a while? Just try this. It says extrude. I don't want extrude. Extract. Wireframe. Organizes wireframe curve structure and nodes and center. Oh, that's helpful. I didn't know that was there. Check the wireframe curves of a BREP. Well, that sounds good. All right. Here's the wireframe. Wireframe isocurve density. Here we go. Now I'm going to set the density to something like 5. Okay, and that was a little bit of overkill. In fact, here, why don't I just skip this? I'll just plug this in here. There we go. Ah, that's much better. I didn't realize that they had a density factor in here. The things you learn on a Monday morning. All right, so let's see. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like 9-ish curves. That works. Why not? I'll go ahead and extract this wireframe. Let's see. Planar curve, curve, planar curve, curve, planar, planar, planar curve. Oh, I see. Some of them are planar and some of them aren't. Well, that's weird. Interesting. I didn't know that could happen. Wild. The thing is, what I'm looking at is like, how do you get one curve, one direction of curves versus the other, right? So I backed myself into a corner here. What I'm just going to do is I'm just going to go ahead and do this in Rhino. Just too complicated. I don't feel like getting that complicated today. Loft. We'll talk more, and actually we'll build a stadium surface and populate that with a bunch of trusses, in which case we will actually pull isoparms in just one direction versus the other. But that's in the next project. I don't even want to skip. I don't want to go into a long diatribe about surfaces today. That's not why we're here today. There we go, loft. I'll select this dude, hit properties, show ISO surface curves. The density, I'll increase the density a bit here. There we are, 4. That looks good. 1, 2, 3. Excellent, all right. And I'm just gonna extract wireframe from this. I'll just type this into Rhino, maybe. There we are, extract wireframe. Select the surface, there's the curves, yay, all right. Couple of other things here. One thing I've noticed is I have my original curves that I lofted. So I have double the curves in a couple of places. I'm gonna go ahead and get rid of those. Ay, ay, ay. Bad Professor Josh. I should be a little more careful and thinking a few steps ahead, but yeah, that's what school's for, make mistakes. If there's ever time to make a mistake, it's now, and not like in the real world. All right. Here we are. All right, finally. That was a really long way of getting to this. And what else do I do? Oh, right. You know, in the video, I think what I did is I just made a copy of these curves and just like sort of, you know, mirrored them and things like that. And I could make another surface. I could just generate another set of curves similar to the process I went through now. But I think just for the sake of speed, I will go ahead and just copy these. I probably mirrored them to try to get them, you know, so they weren't complete copies of each other one-to-one here. Sorry. Double click, there we go. All right, yay. I'll type in mirror and copy yes. I'll just mirror them over here for the time being. And you know what? I'm gonna mirror again, but this time instead of saying copy yes, I'm gonna say copy no. Now I'm gonna mirror them about perhaps this axis. Yeah, that looks good, why not? All right, so what was down here is now up here. I'm just gonna move these through, stagger them downwards a bit. All right. Now I'm just gonna do this top set one at a time here. Go ahead and just delete that. Again, I have some curves here. I'm going to go ahead and set this framework up, then I'll copy and paste a bunch, which is just super way of doing it, but it happens. Could you also bake into Rhino and rebuild it there? Yes, yeah, and exactly right. Yeah, good call, Richard. There we go.
Josh, so when you're viewing Rhino like this, you did it as a shaded?
What's that?
So you did shaded view in order to see? Because when I do
yeah, when you have surfaces, if you want to see them, yeah, if they're in wireframe, you won't see them shaded. Otherwise, you have to put them shaded, rendered, ghosted, X-ray. I like ghosted or X-ray usually. Shaded's fine. I don't really care for rendered. It looks kind of cheesy.
Okay. Thank you.
Yep, no problem. Okay, so I have 3 curves I want to bring in as chords for a 3-dimensional truss. I have 3 curve widgets, and I've just sort of arrayed them in a similar way. So spatially as they are in the model. So set one curve, and I'll select this one, and I'll set this curve, set one curve, and I'll select this one. And last but not least, set one curve, and I'll select this one down here. All right, so there I have those 3 curves. I'm going to build a truss between those. And let's see. So a couple things I'm going to do, right? First, I should probably divide these curves, divide curve. And the number of divisions, that's going to be a variable. So go ahead and add a number slider, right? Go to the params tab. I'll double click on that slider to bring up its properties box, and I'll constrain it to integers. Never want to divide by 0. Math just doesn't like that, hates it actually. And I'll make a crazy range from like 1 to 100 or something like that for the number of divisions. I'll use that. Okay, I'm going to go ahead and copy this division widget 2 more times. So I have this division widgets. I haven't plugged in any curves yet, but this count for the number of divisions is plugged into all 3 of them all at once. So now I can do this, and this, and this, right? Divide each of those curves, each with a widget. And each of those are controlled the number of divisions with this one number slider, right? I don't want to accidentally divide one of these chords up 26 times and another one 80 times. It just wouldn't make sense and nothing would match up. So, all right. So now it's time to make a bunch of lines. Let's try that. Let's go to curves, primitives, line. You'll see that there's a number of different ways you can create lines, more ways to create lines than you ever thought imaginable. But the easiest way seems to be sort of, find the shortest distance between 2 points. So we give it a start point and end point, it draws a line for us. Boom, right? Oops, maybe plug it in here, and plug this one in here. All right, now, what happened? All right, so these curves were mirrored, and now they're going the opposite direction, right? If you think about a start point and end point for each curve, we flip this. So now the start point for these curves on this set are along the left-hand side, and the starting point for the new curves that we made over here start on the right-hand side. All right, so what I'm gonna do is I'm gonna go to Rhino and I'm gonna change all of that. I'm gonna go to Analyze, Direction. So Analyze, pull down, Direction. And I'm going to select all of these curves over here. Not all of these, just these. And I'm gonna try to find the direction. I'm gonna say flip. There we are. Boom. All right. So now we flip them so they're all going the same direction, which is really helpful when you want something that looks ordered and not, completely chaotic. All right. I'll do the same thing over here. I'll plug this, connect these points to these points. It's like connect the dots. Connect the dots, but this is the college version instead of the, kindergarten version. And I'll do this one more time. I'll bring another line widget down. Then I'm gonna connect these back to these. All right. Now we need to do the same thing, but we need to shift each of these lists of points. This gets really confusing after a while. So I'm gonna go ahead and pull these over here, give them a little more space. In fact, have you noticed if you select these, you can actually like align them like centered or left or right. Kind of nice. Evenly distribute them, the spacing. There we are. Okay, so I'm gonna go to Set. I'm gonna go to Shift, List. I'm gonna go ahead and shift to this list. And let's see, this one as well. And this one as well. All right. Now this is starting to look like a tangled bowl of spaghetti. That's why I want to try to get some of these out of the way here. These are all the straight lines. I'll just pull them through. Now you can see, here's all of our shifted lists of points. We're gonna do the same thing. So let's see, curves, lines. I'll just start making some copies. I know I'm gonna need 2 here. I'll go ahead and select both of those at once, copy. Control C, Control V. I know I'm gonna need 2 down here. Control V again, and then I'm gonna need 2 down here. All right, so I'm gonna take this first set of points and connect them up with this shifted list of points. Yay. And I'll take this shifted list of points and connect them up to the regular set of points. All right, now we have our crisscrossing for one of our trusses. So if you think about this, we're building a truss between each of these curves in the next curve, right? So now I'll start here, this with this, and then this with this. All right, and then we have these strays. What this is doing is, remember, we have this wrap value, it's set to true, which means as we remove that first value, and everything shifts up 1 in our list of points. It takes that value that I removed from the top and wraps it around back to the bottom. And so if we set that to false, we will avoid this sort of stray line issue. Maybe, hopefully, false. There we are. Yeah, those go away now. Okay, last but not least, here we have another set of lines. They're orange because there's no data plugged into them, so they're not really doing much of anything. And I'm going to take these set of points with this shifted list of points, and then this shifted list of points with these regular set of points. There we are. All righty. And sort of change that to wrap value from true to false. Okay. Ta-da! Yay! All right. I'm going to go ahead and pull this variable, this number slider out, so we can continually change this and make it more granular or less granular, densify it as appropriate. Let's see. I'm now going to, let's pipe all these things together, right? How's that sound? Let's give these some three-dimensionality. I'm gonna hold down the shift button on my keyboard so I can plug in multiple inputs, multiple widgets into this one input for curves. Do all of these all at once instead of making like 15 different curve widgets or whatever, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I don't really feel like making 9 curve widgets. And let's also pipe these initial chords. Yeah. Now let's change these radius, these radii. Yeah, plural. Radius, plural, radii. All right, there we go. Had to try to remember what I'm thinking about today. So, typically, span and length, begin to inform like the cross-sectional depth and beefiness of your beams and things like that, right? And webbing and chords. So we could measure the lengths of all of these and then, plug those in as, make the radius some sort of function of that. That'd be kind of cool, actually. But let's just plug in dial in a number that actually works really well. Like, is it set to 1, which is ridiculously large. So I'll turn this down to like 0.25 and see what that does. And I'll point these down to maybe half of that to like 0.125 or something like that. I'm not even sure what units I'm using. At this point, it's just sort of more of a visual thing. I can always dial those in because they're variables, so I can always change them later. 0.1, let's get those smaller. 0.2. Did that change? Yeah, it sure did. Okay. All right, so now that I have that, I'm gonna select all of this stuff. This is such a weird way of doing this, but it is what it is. Actually what I'm gonna do, I'll just go ahead and try to center all these things up. Just clean them up once so that way after I copy and paste them a bunch, I don't have to straighten them all up again and again and again. There we are. Okay, let me go ahead and select all of this stuff. Oops. All of it. There we go. Finally, except for this number slider. Everything's going to be plugged into that number slider. So I'm going to go ahead and hit Control-C to copy. And then down here, Control-V to paste. I'll make another set. This time I'm just going to plug in a different set of curves. All right, so the next one's in line. This is such a weird way of doing this, but beats the hell out of manually modeling it still, doesn't it? We'll get to data trees, and again in project 2. You guys will hate me for introducing you to data trees, but eventually you'll see how useful they are when you don't have to copy and paste this 9 times. Z1 curve. All right. And we still have something flipped. Okay, so I'll take this curve and I'll go Analyze, Direction, and I'll say flip it. There. Weird. Okay. So slowly but surely I'm doing this right now. Guess what? I can hit Control-V again. I'll make another copy of this. I'll move it down here. Now here for these curve widgets, I'm just going to change the ingredients. Oh, come on now. Z1 curve. Here we are. I'll select this one, which was the bottom chord. Now it's going to be the top chord of our next truss right below it. I'll go ahead and set one curve here. Select this one out in space here somewhere. There we are. And this one as well. Set one curve. Ay, ay, ay. And this one needs to be flipped as well, apparently. Direction and flip. That's annoying. Did it flip or not? Okay, it sure did. Look at that. Okay, great. These are really sort of long. Let's see if I can select these things. Select that one and that one and that one. I'm just going to move these over a little more. There we go. Yeah. And they just sort of seem a little overly stretched right here. So I'm just sort of manipulating them. And again, you know, I can do that. Everything that flows from left to right. And again, let's say this is way too dense. Right here's my divide count. If I change that, then I can begin to de-densify, if you will. Ta-da! All right, there we go. I like that better. Why not? All right, and so on and on and on and on and on. Should I save that? Not really. I don't think so. Okay, so I'm not going to go ahead and copy this 9 times in front of you. It's just really boring after a while. Open document. Here's the cooking show part. Desktop. Wrong desktop. That's my Mac desktop. Windows desktop. There we go. Oh, sorry, I'm in Grasshopper. I'll go ahead and give you the baked version here. Here we are. Let's see. Yeah, surface isoparms for lattice. Why not? Sure, that works. All right. Any minute now, this will open up, hopefully. All right. Looks like I've been busy in this file. Oh, yeah. Okay. Let me go to my layers. Ah, yes, a bunch of make 2Ds. Super. And what's all this stuff? More layers here than I could shake a stick at. I guess this is why you should really like label your layers thoroughly so you understand what they are later on. Turn some of these off. This is a really heavy file. Yikes. Something just turned off. Oh, okay. All right, so let me turn off all of these curves. Just really is annoying the crap out of me here. All right, there we are. So here's the baked version in Rhino. Yeah, it's all right. It's kind of cool. This is in parallel view. Let me set this to perspective. And let me recenter that. Yeah, that looks so much better. All right, great. So it's all right anyway. Yeah. The baked version. So ortho views, you know, I mean, look, the top's okay. The side version, actually, the side version's kind of interesting. Yeah. Let me see what the top looks like. Let's turn this to shaded. Yeah, actually, all 3 of these views don't look too shabby, I don't think, anyway. Let's see here. Let's fit them. Yeah, that'll do. What I'm going to do is I'm going to do a quick make 2D of the top, the front, and the right side, or whatever you want to call it. So let's see here. In order to do that, I'm just going to go ahead and type in the make 2D command. And select this stuff. Hit enter. For those of you using Rhino 6, there's a few more settings here. If you're using Rhino 5, sorry, you can still use Rhino 5. You just don't have scene silhouette and clipping plane intersections. I wouldn't even worry about clipping plane intersections, to be honest, because we don't have any clipping planes on here. But the scene silhouette's pretty important, so I'm going to go ahead and turn that on. I'm going to turn on tangent line since we have a bunch of curvy pipes in here. And let's see, hidden lines. I'm not going to turn on hidden lines. That's just too much. The hidden lines are going to be a hot mess if I turn those on. So I'm going to go ahead and just make sure these are all selected. Make sure it's going to draw the top view. That makes sense. And I'm going to hit OK. And you're going to see the top view drawing sort of appear over here in the positive X, positive Y Cartesian quadrant in top view. It'll be projected flat onto the XY plane as soon as it's done drawing. Any day now, right now. It's only 111 meg file. It shouldn't be that heavy. having some issues with my parallels, you know, running two operating systems at once. Somehow I'm not sure how Windows doesn't like the amount of space I've allocated, I guess. I don't know. Seems to run out of virtual memory quickly. You know, typical problems. While we're waiting on that, just double check the chat. Don't see anything earth-shattering here. Still
Josh,
just,
before you do the 2D, you don't need to do the like intersects and stuff that you did in the 267?
I'm not going to do that here. I don't really
Okay.
want that. The problem with that would be I would start to get a bunch of hidden geometry where pipes intersect other pipes inside and stuff. So I don't know. We'll see. If I
Okay.
do, then I'll redo this. The other problem is I have a bunch of Make 2D stuff on here and I have that layer turned off because of course. Now this just keeps going. View projection, press escape to cancel. Like, what is taking so long, you silly piece of garbage? All right, I'm going to hit escape. See if we can cancel this out. And you know, golly, this thing is just too darn heavy. I'm just going to take all of this. I'm just going to delete it all. Delete. Yes. No, I accidentally selected everything and hit delete. Come on. Yeah, there we go. All right. I'll go ahead and save as. I'm going to lose all of that information, but I'll go to here. Okay. All right. We'll try this one more time. Stupid Rhino. You know, a good craftsman, everybody uses crappy tools. All right. Here we go. Oop. I accidentally, oh, come on. Sorry, you don't want to magically or accidentally change your viewport zoom. So let's see, make 2D. Really? Having problems just, you know, typing simple things today. All right, let's see if it actually works this time a little better. I've never had issues with this, so. This would be basically 2020 in a nutshell if this didn't work for me now. Just par for the course. Fall 2019, everything worked. Fall 2020,
It was a good
yeah,
one.
you know. It's on brand, isn't it? All right. Big spinning blue wheel. And if I venture to guess up here, I'll get a not. Oh no, this is still trying, I think. It didn't say it's not responsive, so. It let me escape before. Maybe it just has a lot of things to draw. Round things that Rhino takes a while to try to draw. Awesome. Isn't that just great? I'd love to say there was something really interesting or important I could say to fill in all of this empty radio time, but this awkwardness of just not having anything to say and watching the computer think really slowly. Sounds like somebody's using a leaf blower outside, which is weird. Any questions? So the Make 2D stuff I think is really important, and I want to show this to you really badly. I'm not exactly sure why this is acting so, as if this is so computationally intensive. It's not so bad, actually. Oh, 98% done. All right, the progress bar down at the bottom was updating. It's almost done. Yay. This is that part in SpongeBob SquarePants where the French guy goes, 3 hours later. How dense is too dense? You want to be able to see. It's a good question, right? And that's why I wanted you guys between now and next Monday to try this out and then upload drafts, because that's what we can do next week is we can talk about how dense or is too dense or not dense enough, right? I mean, we can, and I would say that it also has to do with the size of the drawing on the poster. So next week we'll actually start plugging these things into the template as well. That'll help you understand that a little better as well. It's a good question. Really good question. Yeah.
For today, what did we need to submit for today? Was it the things
You don't
on-
have anything to submit for today.
Oh, okay.
I believe you. You guys, I mean, you either looked at that video and tried to follow along over the weekend, or you didn't. Not my problem if you didn't. It's your problem if you didn't. So you know, I don't want to. That's on you. It's just.
So we don't need to submit nothing for today for the duty
Correct.
assignment that was? Okay.
Correct. Yeah. Okay, that doesn't look so bad. I mean, it beats the crap out of, or it beats the heck out of drawing that ourselves manually, right? Like from a photograph. That would be terrible. Okay. I mean, I don't think it's that complex, but I don't know why it took that long. I'll just do the front as well, because the front's actually kind of interesting. More interesting than the top. I wish I hadn't spent all that time on doing the top. Let's see. It says front. Sure, why not? What is it doing here? Oh, I see. I'm going to move this away so I don't accidentally draw this as well. Come on. There we are. All right. Make 2D. I'm in the front view. Again, I'm just trying to get some ortho stuff out here. I'll go ahead and make sure these are all set the same way. Hit OK. Now we just wait.
So do we want to stay away from making curves that are like maybe too aggressive initially? Like, do you want more gentle, or is it kind of just whatever you think works?
That's up to you. That's up to you. You know, the question is, it's a good one. And what I would say is that you don't want to end up with a bunch of self-intersections at the end. So there's probably a sweet spot between having something that flares too much in one direction versus the other. Like, I actually think that these contract. I don't know if you can see my cursor. I'm sort of the blue wheel moving around in front view right now. I actually think there's actually some self-intersecting going on here, which you would want to try to avoid, and you might actually see once you start to, you know, really look closely at the drawings and renderings of this stuff. After this, we're just going to do one other thing, which is I'm going to try to pull these apart and start to diagram this, maybe as an exploded sort of drawing. You know, as let's say a companion drawing to this front elevation. I can also begin to make a copy of this, pull each of these trusses apart, so you can see the space in between them, or you create space in between them, so you can sort of differentiate each truss from each other, and then make a drawing of that as well in the same orientation. Let me just move this out of the way. Move these rightwards as well. Here we are. Come on, sometime today. All right. And so in order to do that, you know, there's a couple of different ways you can think about this. You can try to manually select all this stuff. If you're really thinking ahead, you can go to Grasshopper and you can bake each of those trusses and things like that on their own separate layers. That's if you're using, you know, so you would bake, let's say, these on layer 1, and then bake all of these on layer 2, and then bake all of these on layer 3. And what you would end up with is a way to select just this truss versus this truss versus just this truss. Let me see if I have that space frame truss. Here we are.
But how you can bake it to an individual layer?
I'll show you. Let me just open this up.
Thank you.
No problem. Not a problem at all. Truss test. Truss test. Is it? That is not it. I don't know what that is. That's not worthy of its own file. Come on. Let's see. Here we go. It must be this one, which is really unfortunate because this is the heavy one. Surface isoparms. All right. Give me just a second. This has to open up. There's some reference stuff here. I'm going to go ahead and resave this file and delete all the unnecessary stuff. One more time. Save as. Put a 3 at the end of this one. All right, lofting curves, lofted surface, rebuilt surface, isoparms, mirrored copy. Okay, it looks like I need all of that stuff. Everything else can just be deleted. Baked lattice on down, it looks like. All right. Yeah, sure. Yes. Yes, come on, just delete it. Shouldn't take that long. All right. Here we are. All right, so back before we baked anything in, right? There's our surface. You know, I put the lofting curves on their own layer. I put the surface, the lofted surface on their own layer. The rebuilt surface is on its own layer. The isoparms I used are on their own layer, the mirrored copy of the isoparms. I'll just create a couple of layers called O1, O2, O3. I'll make one, let's see, just get rid of all that stuff. Okay, here we are. So here's my Grasshopper file. I've copied and pasted this a bazillion times. There's my first truss. Okay, I'm just going to check this out. There's several different ways you can do this. I can select both of these at once and say solution, baked, selected. And what that's going to do is it's going to bake it automatically on whatever the check marked, the active layer is. Okay. So let me go down here for this set. Let's take a look at that. You know, so if I did the same thing here, what I'd want to do is I'd want to check mark the next layer, right? Before I go solution, bake selected, and then I'll bake that on layer 1 versus layer 2. Versus, okay. Conversely, if I just take each of these at a time and right click on them, I can say bake, and I can select, let's say, layer 3 and hit OK. Right click on that one as well and bake, and then select layer 3 and bake that as well. So you can select everything at once if you're baking more than one thing, and then use the solution, pull down, bake selected. Just make sure you have the right layer as the active layer. Or right, you can just select each of these individually and bake them one at a time. I'll go ahead and just go to bake layer 04, select these, and bake selected. Layer 05, check mark that, select these. Solution pull down, bake selected. Almost as if I planned it this way. Let's see, there they are, bake selected. Looks like I'll need one more layer, layer 7, I'll make that an active layer. I'll select these, yeah, okay, good. Bake, all right. There. Now each of these are on their own independent layers, which is kind of handy. Right. Okay. And this is where, you know, some of this stuff comes in handy, like maybe I select layers 2 through 7, and I say select objects. Right, so I select all the objects on just those layers 2 through 7. So trusses 2 through 7. I'll just incrementally move those down. Let me make sure my ortho is on when I move those. Right. And now I'll just do the same, layers 3 through 7. Select objects. Just go ahead and move those. Just a nice, quick, easy way to select just what you want and nothing more, nothing less. Select objects. Did that work? Wait, what's going on here? Okay, select objects. There we are. To make sure you're selecting the right things, I suppose. That would help. Let's see here. There's layer 5, layer 7. Select objects. Move these. Sorry, let me know if I trail off. Do we have to make these in certain units like inches or feet? At this point, I'm not so worried about that. If it helps you to like say this is going to be an 80-foot span truss or something like that, then you can. it has the implications like when you're using your variables and your number sliders in Grasshopper, right? Those will change depending on what units you're using and the size of things. So, so it's really at this point, I'm not so worried about scale. That's something that's easily taken care of if you're just careful about setting up. You know, let's say you took, I mean, you know, what the interesting thing is if this was a surface from, let's say, a building model I was working on, right? Then I could, you know, basically pull that off into its own Rhino file, reference it in a Grasshopper, generate the sort of crazy space frame structure, even probably bring that into Revit and also generate the curtain wall glazing that would, you know, be deployed along that surface, and then merge it all back together again into a file. So it's really about, you know, what scale and units you really want. And I'm not going to be too concerned about that. That's not really part of what I'm concerned about at the moment. It's a good question, but you don't have to worry about it. The only thing that has implications on is, like I said, is when you're like, say, giving it a pipe radius or something like that, right? So it'll affect that number. This is quite small because I did a radius, like I think by default, when you use the pipe command, it uses a radius of 1. And so, you know, I had to make that. Right, so we can begin to space these things out and then begin to create, you know, another set of, you know, potentially I could, you know, for instance, trace a curve or a line through this and dash it later to sort of show how this thing is exploded and how it would go back together. I could actually turn on the original isoparms, right? And so we could actually have those showing through this diagram. I could beef those up, dash them or something like that. So you can actually make, I think, a pretty interesting sort of set of drawings that are both analytic, you know, talking about how this thing is constructed, as well as what the final result looks like. Okay, I think that's important, right? It's not just about the final result, but honestly, what you've learned is how you know, can basically build this thing, right? Here's another interesting way of thinking about this. I will go ahead and delete all of these layers here in just a second. Right, let's say I could make a 2D of this stuff, you know, similar to the example I showed at the beginning. Delete layers. Yeah, sure. All that work, it's gone. Right. You know, conversely, I could begin to create a set of diagrams. They're all about how this thing was built step by step, right? So, you know, that could go from, let's say, lofting curves to a lofted surface to a rebuilt surface, right? To just isoparms, right? To then the second set of isoparms, right? Then it's about, sorry, let me just zoom out here. You know, I could just select all the pipe widgets all at once and say solution, disable selected, right? And show how we're making each of these connections, you know, and then turn those back on and bake that out in its own separate layers. So you could actually snapshot the process, how this thing's built geometrically if you wanted to, as another set of diagrams. Between now and Monday, I'm gonna do some more examples of this to show you guys, and I'll pre-record some videos that then you can watch if you want to follow along. But I'll prepare some better examples, and those will be inside of the template I give you on Monday as well. What I want you to do is just to go ahead and experiment with the sort of density of these things and doing the make 2Ds and sort of understanding what you get. And really, you know, what I think you should be shooting for is to have what you think is the best version, you know, be able to be submitted by a week from today as a PDF, okay? You know, just a set of like a front, a side, and a top view, ortho view. Maybe try your hand at a diagram like we talked about, okay? And again, the key here is try, right? Like, so I'm not sometimes I'm really prescriptive in this course. Other times I want, you know, where I'm ambiguous is where I want you to experiment. And I would love for you to do something I didn't even anticipate or think of myself, right? I'd be jealous, but that's a good thing because then you get a good grade. You know? So, I mean, where my ambiguity starts is where your creativity and imagination has to take over. Okay, does that help a little bit? Like I'm not being prescriptive in this case on purpose because I want to see what you guys do. Okay. Any quick questions? I'm sure there are lots. Not sure why I'm not sure why my performance today here in Windows was a little off, but whatever. Took a little longer than I thought to make 2D for some things, but
so essentially we're just gonna experiment with the space frame, like multiple space frames, and then
there's two things that you're doing, Clayton.
Mhm.
Everybody listening? It's a good question, right? I should be more clear. Okay. You're experimenting with and trying to develop your own lattice system, and maybe that comes from your Soul Wit wall drawing exercises. Maybe that comes from something that we did in videos 11 or 14. Maybe it comes from something that we did in video 15, right? That's up to you to experiment with and develop, right? But then there's also, parallel to that, you're also extracting ortho drawings between now and Wednesday, right? To better understand what you have, and those can help you with a feedback loop when you start to adjust, let's say, parameters and sliders. But B, it's also, those are the actual deliverables. The drawings of these things are what you actually have to deliver at the end. And so you're starting the first draft of those ortho drawings so that we can talk about the design and density and parameters of your lattice scheme, but also how you're representing it at the same time, right? So we're trying to kill two birds with one stone next week when you just sort of show these first drafts by Monday, okay? And this is recorded. So if you have any questions about what I just said, you weren't listening, as soon as this is up on YouTube, it'll be posted in Canvas, and you can just go to the last 5 minutes of the video and rewatch, and then ask me like, Vermilion, you still weren't clear, but that's fine too. All right. Okay, cool. I think it's really important, just sort of keeping things on track. I'm not going to, honestly, I don't think it's helpful for me to like sort of try to collect everything every day. And, I think, collecting like drafts of, collecting drafts on Monday, a week from now, would be more productive. The other thing I was going to say is that, on next time we meet on Wednesday, you're going to have some more to do for Monday. We'll talk about perspective and doing some quick white clay model renderings, okay, with your model. So the first draft of perspectives will also be due on Monday as well. And those are hopefully simple. I'll show you exactly what settings I want you to use to try to keep these things very simple and won't take too much time. So to me, it's just about following the instructions as best as possible. And then the other thing is, by doing these and getting drafts, if you run into any problems with time, like let's say, golly, Josh, I followed your instructions and still it was going to take like 18 hours to do this rendering. That's really just difficultly impossible, right? Then I can help you troubleshoot sooner rather than later, right? Because I anticipate a couple of questions or problems like that happening individually. It happened last year. And then I have to go in and say, I didn't share your screen. I have to like bend over and look over their shoulder and, sort of tell them to unclick that, click this, turn that off, don't put in so many reflections, turn off the bright reflective metal shader and that kind of stuff, right? Because that's, anytime light bounces more than a bazillion times, and it exponentially grows the time it takes to render. So anyway, that's coming up on Wednesday. Yay. Any other questions? Going once, going twice. I'll be around for the next 5 or so minutes if you have any direct one-on-one questions or anything, but otherwise, class dismissed, and I'll see you Wednesday. Looking forward to it. Go ahead and
See you
stop
Wednesday.
recording here.